Assalamualaikum warahmatullahi wabarakatuh. So how are you doing, my students? You are welcome to the second episode of our class. Like I said the other time, that for this moment, we'll be looking at the solution to the past questions of your mock for last term, that is second term. And as you all know that in the first class, we treated the first part of your section B, that is, immediately the solution to the part 1 of the section B, that is the theory part of your exam past question. And today, we are going to look at part 2 of that section B. And don't forget that for that part 2, I have a total mark of 45 marks. Total mark of 45 marks. That is, you have each question carry 15 marks. Each question carry 15 marks. So let's start from question 11. That's the first question. Now, if you look at this question, the question says that sketch a diagram of a simple pendulum performing simple harmonic motion and indicate positions of maximum potential kinetic energy. I repeat, sketch a diagram of a simple pendulum performing simple harmonic motion and indicate positions of maximum potential and kinetic energy. So the simple answer or solution to this is that you need to draw a table diagram of simple pendulum that's being displaced so as you know that at this particular point, the time the bulb is at this side, it's going to rest a little before coming to this side. So at the point where it's going to rest, it's going to possess maximum potential energy. So there we have our maximum potential energy. Maximum potential equal mgh, while the kinetic energy at this point equal 0. At this other side again, we have our maximum potential energy to be mgh. The kinetic energy here equal 0. And at the middle of its oscillation, that is at the central point here, the potential energy equals 0. Then we have maximum kinetic energy. We have mv squared maximum. So that's the simple solution to question 11 I. So for the second question, that is 11, probably got 2. A body moving with simple harmonic motion in a straight line has velocity v and acceleration a. Has velocity v and acceleration a. When the instantaneous displacement x in meter from its maximum position is given by x equal 3.4 sine 0.8 pi t, x equal 3.4 sine 0.8 pi t. So the question is asking us to find the magnitude of the maximum velocity, maximum acceleration. Also, the question is asking us to determine the frequency. Now, the solution to this is that you write the general, the question you are given, that is x equal 3.4 sine 0.8 pi t. For you to solve this question, you must write the general expression for this. And what is the general expression for this? The general expression is going to be x equal a sine omega t. X equal a sine omega t. So here you just compare and contrast. You compare and contrast. You see that from here, by the time you compare, our A, which is the amplitude of the motion, is going to be 3.4, and the angular velocity, which is omega, will be equal to 0.85 radian per second. Our amplitude, by the time you compare the given question to the general equation, we discover that A is going to be 3.4 and omega, which is the angular velocity, is 0.85. Then from here, we can calculate for the first one, which is the maximum velocity. So our maximum velocity is going to be calculated. Our maximum velocity is going to be calculated using omega r. We are going to use omega r, or we can also use omega a. We can also use omega a. Because we are calculating for the maximum velocity, then our radius becomes our amplitude. At the point where our radius or the displacement is maximum, then we have the amplitude of the oscillation. Then the correct expression we are going to apply here is V maximum equal omega A, and in this case we just substitute. By the time we substitute for omega, we have 0.85. Then we also substitute for the value of A, which is 3.4. You see that our final answer from here, which is V maximum, is going to give us 8.64 meter per second. Our final answer for V maximum is going to be 8.64 meter per second. Like I always tell you people that in physics calculation, we have three main steps. What are those three main steps? The first step is your correct formula. As you can see, V maximum equal omega r omega a, as the case may be. But here we use omega a because we are looking for the maximum velocity. Because our radius here has the maximum value, which is the amplitude. Then that's why we use V equal omega a. So the second step, which is very, very important, is after you've written your correct formula, then you substitute correctly. You can see how I substituted for omega and a. Then the last step is final answer together with the unit. Final answer together with it. So those are the three major steps when you are solving any physics problem. Now, beta. That question said that we should find maximum acceleration. That is maximum acceleration. Our maximum acceleration is given as minus omega square a. Minus omega square a. Minus omega square. So you see this particular question, where we treated, you check your notes under simple harmonic motion. So if you check that simple harmonic motion, you see all this expression there. So you can easily go through your notes and use it to refresh your memory. So from here, since we've determined our omega, we've obtained our amplitude, then we substitute. Therefore, our maximum acceleration will be minus our omega from here is 0.8 pi. So we square the whole of this, multiplied by amplitude. Our amplitude is 3.4. If you use your calculator, to find the final answer. Our final answer will give 2.176 pi square meter per second. Maximum acceleration was 2.176 pi square meter per second. Mind you only leave your answer in this form if the question states that leave your answer in terms of pi. But in the case where the question says that just find the exact value of the acceleration or maximum acceleration, then you substitute the value of pi to be either 3.142 or 22/7. So we go to the next one. So the next question here is that, okay, gamma. So let's find the solution to that gamma. Gamma. Now, that is gamma. This concept is to determine the value of the frequency of oscillation. How do you determine the value of the frequency of the oscillation? Don't forget that our frequency you can use different formula, but it depends on the parameter you are given the question. Now you can use frequency to be 1 over period, which is capital letter T. In the case where capital letter T, which is period, is not given, so you can also use omega equal to pi f. Omega equal to pi f. And from the value we are given, we've already obtained our omega. Then pi is a constant value, 2 is also a constant value. Then we can make our f resolve the formula. So from here, using this now, my frequency will be omega over 2 pi. And what is my omega? My omega from there is 0.8 pi. Then I substitute 0.8 pi over 2 pi. Pi will cancel pi. Then I have 0.8 divided by 2. Then my final answer from here will be 0.4 hertz. 0.4. And don't forget the SI unit of frequency is hertz. You can also leave the value of your frequency in terms of the derived unit. And what that derived unit? It can also be or 0.4 per second. From frequency equal 1 over period. Don't forget the unit of the period is second. That's 1 over second. So you have 0.4 per second. So the leader of the 2 is okay. So that's the solution for the first part of the question 11. So let's go to 11b. 11b. And 11b1 states that state Newton's second law of motion and the principle of linear momentum. State Newton's second law of motion and the principle of linear momentum. So if you check your note, I read your ss3 note, where we treated Newton's law and linear momentum. We treated the impulse, we treated the linear momentum, we treated Newton's first, second, and third law. We also treated the application of Newton's and then the linear momentum. And later in that topic, if you check your note very well, we also treated the lifts or elevators. So how you can determine the resultant weight of a body in a lift or elevator. Now, what is Newton's second law of motion? The Newton's second law of motion says that the time rate of change of linear momentum is directly proportional to the applied force and takes place in the direction of the force. I repeat, Newton's second law of motion says that the time rate of change of linear momentum is directly proportional to the applied force and takes place in the direction of the force. Mind when you are defining this or when you are stating this law, you make sure that the word time rate are mentioned. Time rate are mentioned in your definition. If you omit time rate, you'll be wrong. You'll be wrong, and then you forfeit part of your mark rather. So that is that for Newton's second law. For the principle of linear momentum, the principle of linear momentum states that in an isolated or closed system, the total linear momentum remains constant. Or in a system, in an isolated or closed system, the total linear momentum remain constant or remain the same. Or the total linear momentum remain constant. Or if you like, you can still define it or restate the principle as that the principle of linear momentum states that in an isolated or closed system, the total linear momentum before collision must be equal to the total linear momentum after collision. The total linear momentum before collision must be equal to the total linear momentum after collision. Then, let me still reiterate this on Newton's second law. Don't forget that the mathematical expression for Newton's second law is this. Newton's second law, that is F equal change in momentum over time. That is Mv minus Mu over T. This is the statement for Newton's second law. So that is that for question 11b1. So let's go to the next question. 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 Now look at this question 11b2 says that a particle moves in a straight path with an initial speed u and final speed v in time t. Show that the final velocity v equal u plus at. I repeat, a particle moves in a straight path with an initial speed u and final speed v in time t. Show that the final velocity v equal u plus at. If you can recollect, this is one of the equations of motion in a straight path. And how do you show, how do you prove that the final speed v equal initial speed u plus acceleration times time? Now don't forget, if you want to prove it from the definition of acceleration. And what that definition? Our acceleration equal change in velocity or change in speed over time. That is final speed minus initial speed over t. So from here, we can just make our final velocity subject of formula. From here, a equal v minus u over t. We can just make our final velocity subject formula. So just cross multiply. If you cross multiply, we are going to have v minus u equal 80. Then transfer minus u to this side. I have v equal u plus 80. So as simple as this. So my dear students, we've come to the end of today's class. Next time I come your way, I remain your Malam Salako Najmedin. Don't forget, if you have any question to ask me, you can reach me on my WhatsApp number. Reach on my WhatsApp number is 070-6593-3261 or my email address. My email address at salakonaji@gmail.com. Bye for now.